Okay. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. So, my name is Mohammed Faisal. Today, the date is October 23rd. The time is 10:42 a.m. Eastern Daylight Time. I am the Chief Examiner at Nafi. We have with us Mr. Syed Asad Mehmood. He is going for his diploma in Artificial Intelligence Operations, EduQual Level 6 RQF Level 6 exam. The topic you have today is orchestrating genomic data processing pipeline with Nextflow, Cromwell, and Kubernetes for precision medicine. One of the things that I'm working on right now in raising capital is also trying to establish a new company which is working on drug discovery, right? Genomic mapping, genes mapping, many other things, right? So essentially, in our DNA, we can see what kind of diseases we can end up with, right? In the future, what kind of markers do we have? For this, there's a lot of precision medicine is a new field which is now coming up. There's a lot of work being done in US, in China, specifically in China, they have gone way ahead, and many other organizations and many other countries and large-scale pharmaceutical companies are working on all of these things. Because of AI, things are getting accelerated. To give you an example, the time difference. I was listening to the news this morning on a radio, on my phone, after Fajr Salah, and I was listening to it. And in UK, they have to take, pictures like of the seabed, right, in the ocean, to see what kind of damages, damages is what kind of damage is being perpetrated on the ocean floor because of the atmospheric conditions, environmental changes, and stuff like that. And they said like it to analyze one picture, it took them 8 hours, 8 human hours. The human is looking at the picture, trying to find differences, right? Because of AI, now by the time they submit the picture and they're coming back, they took the picture from these autonomous submarines, like smaller ones, and by the time they come back, they already have the data and the results there. This is the speed of image analysis because of artificial intelligence. You see, the world is accelerating at a very faster pace. Similarly, there is a tree of life. The tree of life is something which is tree of life, in medicine. This is basically a set of trees which has medicinal properties for liver, heart, cancer, treating wounds, pain, all of these things, right? So in the London Botanical Gardens, they're using the tree of life and analyzing the properties for creating precision medicine, right? So you can imagine this is the next evolution. If you really want to be successful and take this further, inshallah, you won't find people working in this sector. And there's a huge demand, but the supply is not there, right? So today's topic, when you present it, this is what I would like to see. As per the topic, the project requires students to design and implement a scalable genomic data processing platform, supporting whole genome sequencing, variant analysis, and personalized medicine applications. The solution must handle petabyte scale genomic data sets. This is huge, right? Huge sets. Ensure HIPAA compliance, and integrate with clinical decision support systems, preferably based on AI. Students will build a cloud-native bioinformatics platform supporting collaborative research and clinical genomics workflow while maintaining data privacy and security. So there are some specific key learning objectives: genomic workflow orchestration, scalable genomic data processing, cloud-native bioinformatics infrastructure, genomic data management and security, variant analysis and annotation, clinical integration for decision support, and industry applications. There's also an element of open source cloud native tools that you have to show how you can embed them. The presentation is going to be minimum 15, maximum up to 20, 25 minutes. You have to present the topic, followed by a Q&A, which can last from 30 to 40 minutes. So the whole thing can be wrapped up to between 45 to 60 minutes. If at any given point in time you cannot understand what I'm asking you of the question, you can always ask me, can you please repeat the question? And I will try to break it down further so that you are able to answer. Do you have any questions, Syed, Asad, Mehmood, before we start?
No, sir.
Can you hear me clearly?
Yes, sir.
Because there is a delay. When I ask you, can you hear me clearly? You think, you blink, and the answer comes in few seconds, right? So I just want to make sure there is no communication issue or anything like that, okay? All right.
Okay.
The time is 10:48. You may start your you can share your screen, please. 10:49, you can start, inshallah. So share your screen, please.
Is screen visible?
It's loading on my side. Give it a minute. I can see the screen. It's 10:49 a.m. You may start now, please.
Bismillahirrahmanirrahim. My name is Syed Mehmood. Today I am presenting topic orchestrating genomic data processing pipeline with Nextflow, Cromwell, and Kubernetes for precision medicines. Genomes is the fastest growing areas in the medicines. Every human genome contains 3 billion letters, and sequencing it produces massive amount of data. So we need secure, scalable, and efficient bioinformatic pipeline. This is what I will explain today. Before we dive further, let's see the table of content. In the introduction, we will see what is genomes, why we need sequencing, and what is the important precision medicines. Then in the genomic data processing, we will cover how we pass data through different stages and convert raw data into a actionable insights. Then we integrate this data to the hospital systems where the doctor can see the result and then treat the patient accordingly. Then in the genomic orchestration, we will automate all the steps. Like we build pipelines that will all automate all the steps. Then scalable data processing and cloud-native bioinformatics infrastructures help us to scale our pipelines and use distributed computing. Then in the genomic data management security, we will see how we use different storage systems to store our petabyte scale data and we secure it. Then in the high-level architecture, we will see its all component in the functionality. Then genomic data are widely used in different industries, so we will see later. So what is genomes? Genomes is like the instruction of how our body works. Scientists read DNA because they want to find the exact order of nucleotides, such as ATC letter. By doing this, they can find mutation, understand disease, and develop a personalized treatment. But DNA is extremely long. We cannot process it directly. So what we do, we fragment it into pieces and then put it into a sequencing machine that produce a digital FASTA file, which is like the digital data. So we can analyze it through. So important the precision medicines. By analyzing a person's DNA, doctors can develop a personalized treatment according to person's genetic makeup. For example, if there is a mutation BRCA1, and the doctors can recommend targeted therapy instead of chemotherapy. This helps us to avoid side effects and give better outcomes. It also helps in the early diagnosis and the risk predictions, and it helps us to do fewer trial and error. But we have some challenges. Genomic data are very complex and very large, so storing, processing, and maintaining is very complex. Then number two, many samples come from different populations, so data inconsistent is also a challenge. Then after finding variants, we need to understand what is clean, that is cause disease, is harmless, it's also a challenge. Then privacy and the ethical concern are the biggest challenge because genomic data are very complex. If it's not handled properly, it will be very important to handle it properly, and we need to follow laws like frequent GDPRs. Then machine learning and interpretability. Machine learning are very useful. We train on the data, and then it can predict whether a person has disease or not. But the Results should be explainable because doctor don't just want to see the result; they want to know why AI is giving these results. Then the next is clinical translation accessibility. After finding variants, we have results, but we need to integrate this data to the hospital systems where the doctors can see the genomic data with patient history, so they treat accordingly. But to solve all these problems, we use different techniques. We will see. The first is genomic data analysis. After we have DNA FASTQ files, we need to align that because previously we fragment the DNA and they put it into a sequencing machines. So we need to align that. But before that, we also do pre-processing, like quality control checks to see if the reads are high quality, and we remove the contaminations. Sometimes we adjust the coverage and the quality of the reads. Then we perform alignment. In the alignment, we that map the reads back to the reference genomes. Reference genomes is like a guide which help us to map the reads. For example, it's like a guide that tell us how we map the reads. We use tools like BWA, Botty2, and stars, and it helps us to align the reads back. Then we perform variant callings. In the variant calling, we look at the places where the human DNA is different from a reference genomes. It helps us to find the differences in the DNA. The tool we use is EduQual haplotype caller or muted2. This helps us to look at the places where the DNA is different from a healthy people or the reference genomes. Then after finding variants, we don't know what it means. That's where annotation steps come in. What it does, it takes the variants, it checks against different databases like ClinVars, PVSNPs, Cosmic databases, where the variants of exist like where the clinical variants exist, Cosmic, where the cancer-related database variants exist. So we check against this, and then we explains that this variants cause disease, it is a harmless or doesn't change protein structures. So it helps us to provide summary. Then we convert this into a summary. So we have seen we have FASTQ files, which is like a DNA, we did alignment, we map the read back, and then we perform variant calling, where we look at the places where human DNA is different, and then we perform variant annotation. We give descriptions or explain to these variants, and the output we save in the BCF file. Then the workflow orchestration. Why orchestration is needed? As we discussed, we need to pass the data through different stages like alignment, variant callings, and the annotations. But we need to make, manually doing this is error prone and will consume a lot of times. That's where orchestration comes. We use orchestration tools such as Nextflow, Chrome wells that are very useful because it manages dependencies between the tasks. It helps us to retry the failed jobs. These portables and reproducibles means we can run on different environment and get the same results. Chrome well also well integrated with EduQual and Nextflow had a ready-made pipelines to NF community. Then we have Airflow. It's also an orchestration tool, but it's more like a monitor of the schedulers. It is used to trigger the pipelines such as Nextflow and Chrome wall on the specific times. It also manages dependencies between the pipelines, and it uses DAGs, which shows how tasks is sequence on the iterators. Airflow also has rich UI where you can monitor your tasks, you can perform reporting on the machine learning. Then we have clinical integration and decision support.
You have taken a pause?
I think that it will disconnect. Then we have clinical integration and decision support. After getting the result, we need to integrate these data to the hospital system where the doctors can see the results. But we have problems because every hospital uses different formats. So we need a standards that everyone can follow. That's where FHIR, HL7 come in. What it does, it takes the variants and then convert the result into a format structure, into resources like patient resource that carries the patient result, observation resource that carries the variants and the diagnostic report that summarize all the key findings. This helps us to integrate this data, and through API, this data is integrated to the EHR system where the doctors see the results. We have another tool called CDS. CDS is a clinical disease support system. It's like a smart assistant that gives alerts of the recommendation to doctors. It fetches data from the FHIR, and it's also integrated with the medical knowledge and the patient history. And then by combining all this data, it generates or gives recommendation to doctor. Does we need to adjust the dose, or do we need to change the medicines, or what is the best treatment for the patients? It is very useful because it reduces side effects and improves outcomes. So we have the lab results through FHIR mapping engine. We convert into a resources and store in the FHIR server. And through API, we integrate these data to the EHR system. CDS system also helps us to give support and give recommendations whether we need to take another medicines or need other treatment or etc. Then scalable data processing comes. So why we need scalability? Genomic data are very huge. Single human genome will contain gigabytes of data, but in the lab or hospitals, we not only process one genome, we need to process thousands of genomes, and the data goes in the terabytes. So we need a secure, scalable infrastructures, and that's running them on a single machine is very slow and it takes a lot of time. That's where distributed computing comes in. What it does, it takes a task, for example, read columns, and then it breaks it into multiple pieces and run them on parallel on the nodes or clusters. And then after performing processing, it will recombine the results. This way, we get the result in a very fast way and will save a lot of times. The tool we use for distributed computing is Spark, Task, and Ray. Spark is good for big data analytics engines. It is widely used in the genomic data processing. Task is a Python-based framework used to scale libraries such as NumPy and Pandas. Ray is good when you need to combine AI with the genomic data. Cloud-native infrastructures help us to scale the pipelines and use different machine or containerizations to process data. We use Kubernetes. What it does, it will containerize all the tasks, and it will make sure that every task will be isolated. And it will also help us because it is used to auto-scale the resources based on the need, because economic data are very, sometimes it's come in very large quantity and sometimes in a small quantity. So it will adjust the loads and the plot accordingly. Then it is very good for reliable for thousands of samples. Helm is a package manager for Kubernetes. It is used to install tools. We have different tools, so Helm allows us to use ready-made templates and deploy it. It is very helpful because it follows reproducibility. You can deploy in a very fast way. Then Argo Workflow is also an orchestration tool, but it is built on Kubernetes, so it's basically well integrated with Kubernetes. It's also used to automate pipelines such as sequencing, alignment, and columns. It is also make sure that tasks should run in the order or in parallelly. It also uses tags. It also has rich UI where you can monitor your pipeline workflows. It will also help us to save time and improve reliability. Then in the high-level architecture, you will see we have orchestration layers where we have orchestration tool like Kubernetes, Helm, and the Argo workflows. And we through this we trigger the pipelines such as Nextflow and the Cromwell. In the Cromwell and the Nextflow, these are the pipelines where we have different steps. We write different steps, and we use tools like PWA, Star, and GAPK that perform all these steps. It can use the backend can be local, cloud, or depending on requirements, and we can also use distributed computing such as Spark, Task, and Array. And the result stored in the storage system, it could be Lustre, IO, and Ceph, depending on which storage system we are using. Then this result is then integrated to the EHR systems through integration layers, as we discussed through FHIR, HL7s, which convert the data into a resource format so that every hospital can understand and integrate this data. We often need to make sure that every step of my pipeline should follow laws like HIPAA and the GDPR, and the best practices and fair principles such as 3A4J and the fair principles. Then data management and security. So why data management and security? As we have seen, the genomic data are very huge, so we need scalable storage systems that can easily handle data and the gigabytes of data. That's where we have different storage systems like MinIO, S3, and the MinIO set and the Lustre. MinIO is like S3 compatible storage. It is very fast and very scalable. You can scale thousands. You can store thousands gigabyte data sets, and you can deploy it on-premise. It's like a private storage system. Ceph is good because when you want all object, log, and the file storage in one system, it is very good because it also provide high input output. Then we have Lustres, which is a parallel file system for HPC. It is good because it provides very high input output. It is best for tools like variant callings and the alignments because the tools require very high input output. So Lustre help this problem. Then we also need to make sure that we follow laws like HIPAA and GDPR that protect patient health information. We need to make sure that our data should be protected, encrypted, both at rest deposit, access policy should be enabled, and logging should be enabled, and data should be anonymized, and make sure that every step of pipeline should be protected. Then there is standards for 3A4J and the FAIR principles that allows us to share the data across hospital systems with privacy. FAIR principle says that data should be easily findable, accessible, interpretable, usable. Means we should define how our data is stored. We need to include metadata, and we need through proper permission we can access the data, and the data should follow standard formats, and it should be stored in the version control with tags. Genomic data are widely used in different industries, from healthcare, agriculture, biotechnology, forensic industry, and pharmaceutical industries. In the healthcare, by analyzing a person's DNA, we can develop a treatment according to person's genetic information. This helps us to improve patient health. For example, some patients metabolize drug too slowly or too fast. It helps us to give the dose that will work for us, will work for him. Then genomic data are widely used in the agriculture, where it helps us to improve crops while making them more resistant to disease and environmental stress. In the biotechnology, it is used to improve productivity of animals. Then in the forensics, genomic data are used for DNA-based identification in the criminal investigations, and the scientists can read the DNA and can find the origin of the families. Pharmaceutical companies are widely used this data because by analyzing a person's DNA, they can develop a targeted drug that will work best for the patient. It helps us to avoid side effects by giving right dose at the right times. To conclude it, we have seen that genomic data are very large, complex, and sensitive. So we use different techniques and tools that help solve these problems. We use workflow orchestration tools like Flow, Cromwell, and Airflow, and we also used cloud-native infrastructures that help to scale our bioinformatics pipelines. We need to also make sure that our pipelines should follow laws like HIPAA and GDPRs, and full compliance and should follow standard best practices and the FAIR principles. Then we have seen that genomic data are widely used in different industries, from precision medicine to pharma, biotech, forensics. Thank you. Now, thank you.
Okay, Jazakallah khair. Okay, Bismillah ar-Rahman ar-Rahim. So let's jump into the Q&A. As I always start, like I always give the first few questions, the 5 ones are within the domain. Like I would say, It provides everyone ample opportunities to score as much as they can, right? And then the last five are the tougher ones. Okay. So the topic is tough, but you know, even if you go to a company, you don't need to know genomics in terms of like the different strands and how many strands are there, the possibilities and all of those things. No, right? Your job as an engineer, as an AI engineer, as an AI architect, or as an AI ops architect is to design the solution, right? So we will focus on the solution part. What is the primary purpose of orchestration tools like NetFlow and Cromwell in genomic data processing? Why are they important in this specific case?
The main purpose of this orchestration tool is to automate all these steps because if we do manually, it will consume a lot of times and we need to manage dependencies between them and will error prone. That's why the use of orchestration tool like Nextflow and the Chrome walls that help us to write each steps. It help us to integrate bioinformatic tools and it will manage dependencies between them. It also retry if the job fails. It will save a lot of time.
Okay. If I have to give that answer, I will say, you know, they what my question was what are the prime what is the primary purpose of orchestration tools like NetFlow and Cromwell? I will answer like this because when you go for a job interview, they might ask you a question, right? Like this, where you have to be able to answer. So you will say, these tools, sorry, and Cromwell, they automate multi-step bioinformatics workflows, ensuring that at each stage, such as alignment, variant calling, annotation, all of those things which are mentioned in your presentation, runs in sequence, reduces manual errors, and increase in reproducibility because you have to reproduce the results, right? In research purposes, you have to reproduce. If you can't reproduce the same results, then they are inconclusive. The next flow provides scalable pipeline execution, which is the most important part. Why are we using Nextflow? While Cromwell executes, the WDL, the workflow description language based pipelines efficiently. Do you see the difference between yours and my answer? You will learn this through the labs. Now, all those people who are going through their lectures, right, their exams, you can only get access to the labs once you pay the examination fee. So the earlier you pay, the better it is, right? Now, for the older ones, the older students, they have to continue their access until they complete the labs. That's something I can't do anything because these are new features which we are adding, right? There are new things coming in. You have to do the labs, Syed Ahmed Mehmood. That will give you the confidence you need to be able to answer these questions. Because in your KYC-based labs that you will receive on the 7th, 8th month, you will be doing the same project in the form of labs. You will install Nextflow, you will install all of these Cromwell, all of these tools, configure them, address them, import the genomic database, and see what happens. Okay? All right. So why is distributed computing essential for genomic data analysis? Like, why do we need it? In today's age, why is distributed computing essential, specifically in your purpose?
Distributed computing are very important because when patients come in the hospital, they need treatment immediately sometimes if the health is critical. Uh, Distributed computing help us to parallel the task. It helps us to run the task parallelly and then give the result in a very fast way. Uh, Distributed computing help us to break the task into smaller parts and then it will give the result. Basically, it will save a lot of time. And it also help us to manage the
Okay,
resources because
let me
sometimes we
ask
have
you, let me ask you, a single human genome produces how much data?
Gigabytes of data.
Sorry, what?
Gigabytes of data.
Gigabytes, right? A single human genome, like which you can't even see it through a normal microscope, right? You need these are mechanical microscopes which are very powerful. At my home, my iPhone is not here, it's charging iPhone 14. Long ago, there was a new device that came up, right? So in my home, I have a normal microscope. So we have the whole kit of how to, slice up a portion of the blood and how to put it in there, put some glycerin, put we call it these strips, right? So you put on the strips and then you start, focusing on on the image, right? So I got this new gadget which was able to be connected on top of the iPhone camera, and then you can connect it to the to this microscope, and it was able to zoom in much further, right? The new iPhone 17, has a much high definition. So a time will come that we'll be able to even see by using a simple iPhone to be able to see zoom in into all of these things, right? What I'm saying is like it creates that small strand creates gigabytes of data, right? So this is how you have to answer the question, right? This is how you have to answer the question. I mean, the question needs to be presented in a way that when the employer is listening, he's saying, Syed, you know, uh, Asad, Mehmood is our guy, right? The only way he can say he's our guy is if he hears from you how you have to talk. So you will say, my question was, why is distributed computing essential for genomic data analysis, right? Why? So you will say, a single human genome produces hundreds of gigabytes of data. Essentially, you can say, hundreds of gigabytes means like almost 1,000 gigabytes of data, 1 terabyte of data. When analyzing thousands of genomes, so that's one person creating almost a terabyte of data. And when you are analyzing thousands of genomes, the total data volume scales to terabytes or even petabytes, right? Do you see how I'm answering the question? Sayyid Asad,
Yes, sir.
समझ आ रही है किस तरह जवाब देना है? This is how you have to answer. Al-Razak prepares you for that. The labs, when you keep on moving forward, the advanced labs, the AI is going to communicate with you. Answer me this question. Why is distributed computing essential in today's world? In today's world, whether there's genomic processing or whether like mass amount of data, that's where distributed computing comes in. So you will say, when analyzing thousands of genomes, the total data volume scales to terabytes or even petabytes, zettabytes, right? It's getting bigger. Distributed computing frameworks like Spark, Dask, Ray, all of these different open source tools available, divide tasks into smaller chunks, process them in parallel, and drastically reduces analysis time. That's how you have to answer. So when the interview is over, listen to your answer and listen to my answer. I didn't use any fancy words. I just explained your presentation. Right? इस तरह तुम्हें जवाब देना है. If you answer like that, you will get the job. The first 5-10 seconds is where like you will get the attention of the interviewer, who is, the panel who's sitting and interviewing you. The first 10 to 20 seconds, when you open your mouth, they will be like this. Someone will be drinking their coffee, right? They're not paying attention. But as soon as you say something, they will say, what? Wait a minute. Okay, you got my attention. You only have 20 to 30 seconds to get the attention. And that always happens during the first question. Be articulate. Okay? Eloquent. अपने आप को थोड़ा सा और बेहतर बनाओ इंशाल्लाह. Okay? All right. So let's go back further. How does Kubernetes improve genomic workflow execution compared to traditional infrastructure? Why not traditional infrastructure? Why are we using Kubernetes?
Uh, Kubernetes genomic data sometimes comes in very large quantity. So we need a scalable solutions that can scale automatically. That's where Kubernetes comes in. The first thing, it isolate the tasks. So it isolate all the task and dependencies. And the next thing, when the data comes in very large quantity, it uses let's say autoscalers or HPA, horizontal pod scaler, and it will automatically scale up the pods, process the data, and then scale down. This
You
helps
use
us
all
to
the, that's it.
avoid.
That's it. Answer is done. You use all the core topics like the keywords, horizontal pod scaling, vertical pod scaling, auto scaling, right? So you did all of that. So, but the answer is like, you got some score, not the full marks, some score, right? Half of it, more than half,
वही सर
right? No, you get the
internet
answer. The
connection.
answer say the your answer is right. You got out of 2.5, you got 2, right? It can't be a long answer, it has to be short. So this is how you have to say, you know, the difference between, what is the difference between traditional and Kubernetes infrastructure? First of all, the Kubernetes infrastructure, we already know about the data and all of those things, petabyte, zettabyte, the data keeps on growing, right? The traditional infrastructure, what are the bottlenecks of the traditional infrastructure? The traditional infrastructure have the bottlenecks of you can't scale them easily, whereas horizontal scaling, vertical scaling, right? There is no self-healing, there is no auto scaling, all of these things. This is traditional. The new one, Kubernetes allows containerized genomics applications, the ones that we have like GATK mentioned in your presentation, BWA, VEP, to be deployed, scaled, and managed automatically. It ensures auto scaling, fault tolerant, and resource optimization, making the system robust for processing thousands of samples simultaneously. Khalas, that is how you have to answer. Don't give me an academic answer. We expect a lot from our candidates, right? When you go forward further in doing these labs, it will record your voice samples. वो तुम्हारी voice record करेगा, तुमने answer क्या दिया, and then it will give you the feedback. Not good answer. This is how you have to answer. Again, if it's a good answer, then say okay. Because our goal is what? What is your goal? Why did you do this? After intermediate, तुमने enter किया. Why did you study this qualification? What is the number one purpose? क्यों पढ़ रहे हो?
To get practical, I don't.
No. The number one purpose is to secure a job.
Yeah.
यही है ना? Secure a job. Once I secure a job, then I can see, okay, once I have the job, I can be financially stabilized, do all of those things, right? I say, that's why you're studying. To secure the job is number one objective. You saved all of your time, 4 years instead of studying at Air University. You jumped in, and within 1 year, 1.5 year, you completed all of the tasks, right? I can tell you in your presentation, right? You secured good marks, right? Based even on that, you will pass the exam. But we just not only want you to pass the exam, we want you to secure the job, right? That is our task. Does the university take that responsibility? No. We are taking that responsibility on our own to make sure that our graduates get the job. There's a job portal now where we are inviting all the GCC companies to come in and post their jobs. They're doing that right now. There are more than 2,000 job titles. And I've invited more than 70,000 companies, which are publicly registered companies in the world, to come on and post their jobs. And they already started doing that. So when you go there, you're representing us, right? You have to be the best. That's all I expect from you. What role does FHIR play in integrating genomic data into healthcare systems? What role does it play? What does FHIR really means?
FHIR is a fast healthcare interpretability resource.
Research.
It's basically
Go.
it's basically It's basically FHIR is basically uh, it is basically used to integrate the data to an EHR system, which EHR is like the electronic health record systems. So basically, when we have results, we need to make sure that every hospitals can integrate these data because EHR, every hospital uses different EHR systems, and we need the standardized uh, data. That's where FHIR comes. It will convert the data into resource formats, and then through API, it will integrate this data to the EHR systems.
Okay, good. You know why I know? You know why I know this thing? We have our own clinic in Canada. It's known as Cedar Brae Medical Center, right? Uh, let me show you. So I'm showing you some things so that you can understand, right? This is the Cedar Brae Medical Center. This is our clinic here. There are more than 15 doctors working, multiple doctors, so on and so forth. This is their website. The website is not that good because, these are all the doctors, right? We will be, inshallah, opening another like couple of these clinics in Riyadh, in Jeddah, and all these other places as well, inshallah, down the line, right? So this is Cedar Brae Medical Center. You know what we use? We use TELUS EMR. The TELUS EMR, right? This is the TELUS EMR. It's a very advanced, the PS suite. It's very good. All of these companies, clinics, they have to use TELUS EMR, right? The FHER system is designed so that it can import data from EMR automatically. That's the FH, IR standard, right? So you see workflow efficiency, informed patient, remote EMR access. So when you are importing the data from the EMR, what happens is you need to what do you have to do when you have the patient information and you have the genomic information? What are you going to do with this data? That's a good question for your exam.
We convert this. We want to integrate this data to the hospital systems where the doctor can see the results, genetic variants, or the summary of the overall.
Good job. Good job. Okay. The reason is that the doctors need to see the patient data, and then you're also pushing in the genomic data as well, importing that into the EMR to show what are the risk factors or the risk traits of that given, basically patient. Whether you want to do it analysis at the back end, at the front end, how you want to display it, that is the role of FH, IR, right? Which plays a very critical role because fast healthcare interoperability resources, right? It standardizes the exchange. So you have to answer this question in a way. The FHIR, which means fast healthcare interoperability resources, like interoperability means it is operable, it can work with different kinds of EMRs. It standardizes the exchange of health and genomic data between systems, allowing genomic results to integrate directly into EHR, electronic health records, or EMRs for clinical decision support. You see my answer and your answer? Improve your answers. You got the score. You got full score on this one, but it has to be better. I want you to get the job. In Canada, in USA, in UK, thousands of jobs are available for people who know this topic. They can secure the employment because this is one of the pain points. And all of these big companies like TELUS and all of these companies, they're working and they're looking for engineers. If you are an engineer who has completed AI Ops, if you are an engineer who's completed Al Razak Labs, who knows about Linux, Dockers, containerization, have QB astronaut under its belt, have golden QB astronaut under its belt, it knows architecture, it has good communication skills. The moment you land, they will come and say, when you go to the airport, you see people, with a card, right? With a name on it, right? कभी एयरपोर्ट पे जाओ नजर आता है ना असद अहमद शाह इधर आ जाइए, राइट? एक बंदा कार्ड लेके खड़ा होता है. Companies will come after you like this, say, Syed Ahmed, Mehmood, we are here to please come and so that we can take you. This used to happen during dot com bubble. They were importing engineers and bringing it from all over the world in the 1980s and 2000s, right? This happened. If you read the books, you and me, we haven't seen it, but I read the book and I saw some of these clips. That's how companies were looking for engineers. So if you have the skill, you can be there, inshallah. Okay? All right. Power play is done. It's going to be tough now. Okay? 3, 4, 7, 8, 9. Okay. All right. Bismillah ar-Rahman ar-Rahim. So, how do Argo workflows differ from Apache Airflow in orchestrating genomic data? Are you there, Syed Asad Mehmood? Because your picture is stuck. Are you there or not? Who's there with me on the interview? कौन है मेरे साथ यहाँ बैठा हुआ?
हुसैफ, I think तो डिस्कनेक्ट हो गया.
Disconnect हो गया. Okay. He's going to lose the time because I have to wrap this up, right? I'm going to go for the second question now.
Sorry, sir. We're going to no issue.
We are losing time. Okay, so so you have to be fast. Were you able to listen to the question I said?
No, sir.
Okay, I'm going to repeat this again. How do Argo workflows differ from Apache Airflow when it comes to orchestrating genomic data? Go.
Apache Flow is basically for like EduQual jobs or for bioinformatics, but Argo Workflow is basically built on Kubernetes, so it is very integrated with Kubernetes. It can be used secret. It can be easily integrated with secret manager, configs, and it isolates. So it run the steps in containers, isolated containers, while Apache Flow is basically used locals or nodes.
Okay. What are the security and compliance implications for the genomic data storage when it comes to the cloud?
Sorry, sir, repeat the question.
What are the security and compliance implications for the genomic data if you have to store them in the cloud? What do we have to take into consideration?
The first things we need to make sure that data should be encrypted, both at rest and in transit, and the access policies will be applied for the policy so that only authorized user can access the data, and logging should be enabled, and data should be anonymized.
Okay. What are the FAIR principles and how do they align with the genomic data ethics? What does FAIR stands for?
FAIR principle is FAIR stands for findables, accessible, interpretable, and reusable. It is a standards that help you find the data. For example, it says that you store the data with metadata ID, so you fetch the data, and data should be accessible with the proper permissions, and it should follow standards files like PAN, VCF, and every pipeline should tag and sit in the version control for reusability. This ensures that it helps us to collaborate across different hospitals or the labs.
Okay. So this is going to be related to the GA4GH, right? So I'm going to ask you a question regarding that. Explain how the GA4GH standards, the FHIR standard that I asked you, the FAIR standard, and the Kubernetes together form a compliance-driven decision-making medicine ecosystem. how can we, what are the benefits, and can we create something like that as you proposed in your architecture?
Can you repeat the question?
In your presentation, there are different interoperability and sharing standards, right? And protocols. Explain how the GA4GH standard, the FHIR standard, the FAIR standard, and Kubernetes together form a compliance-driven precision medicine ecosystem. How can we achieve that? What are the benefits of all of these things that I mentioned? And can we achieve a precision medicine ecosystem?
Yes, we can achieve it. We can use Kubernetes. We can create different namespace for the project, or we isolate the resources. We make sure that we apply resource and quotas, and we need to version controls all the. We need to make sure that every workflow should tag with the ID and be saved in the version control systems. And GA4J the standards that implement laws. It allows to share the data across different hospitals and the labs. We use GA4J frameworks like HDF, or we have different FHIR resource and WGET. This allows us to
Okay, let me quickly ask you. So let me quickly ask you, the GA4GH standard, what do we use it for?
It is basically used to share the data securely across hospitals and the labs.
What does it? So hold on. What does it stand for, by the way?
Global.
The GA. Yes, go ahead.
Global Alliance. Global Alliance for
Genomics and Health. Right?
Genomics and Health.
That's what it stands for. Wherever you go, in every pharmaceutical company where there is research going on, one of our student, long time, he's worked at CDC, Center for Disease and Control. That's where they follow these standards. These standards are the international standards that is followed by wherever you go in whatever part of the developed world, like in the North America, in European Union and Scandinavian countries. This is what they follow, right? And even in the GCC, right? So that's what it stands for, which is used for what?
It is basically used to implement laws.
Sorry, come again. What is it for?
Standards. It is used to basically implement laws, to follow laws. Like it has standards, which is like HTS and different standards that help us to
hold on.
share
GA4, hold on. GA4GH standard is not for loss. You mentioned loss? Laws.
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 Enforced laws.
No. So it's not for laws.
Like,
the GA4GH defines interoperability and sharing protocols for genomic data globally. That's what it is. So if there is a company in US and they want to send the genomic sequencing data to some company in Europe, then they have to follow the protocols as per this standard.
I mean,
it's not a law. It's not a law. This is the GA4GH it's not a law. It's basically a standard. It's a non-profit organization. Yeah, it's a non-profit organization.
That creates standards.
They're just developing standards, right? So standards are developed and you have to follow them. It's up to you. If you don't follow them, other people will not do business with you, but you have to follow them, right? If you want to be globally relevant. The FHIR, what does it do? You already answered that question.
FHIR is basically convert the data into a format where the hospital can easily understand.
So it's for clinical data communication, right? With EHRs, electronic health records. Kubernetes is used in this scenario for what?
Kubernetes is help us to isolate, containerize the task, isolate the systems, and it is for use for scalability, and it helps us to retry the failed containers, retry the failed task with the, and it also resume it with the we can define checkpoints in the workflow engines, and
So
workflow will.
this is the final question, but you have to answer it like this. The GA4GH defines interoperability and sharing protocols for genomic data globally. The FHIR standardizes clinical data communication with EHRs, right? The Kubernetes ensures secure orchestration of the entire data cycle from sequencing to clinical decision support. Combined, they form an end-to-end regulatory compliance system, right? Ensuring scalability, standardization, availability, self-healing, data privacy controls. That's what it does. That's how you had to answer, right? Okay, from the architecture diagram that you proposed, this is the final question. Propose how to design a fault-tolerant pipeline that continues genomic analysis even if one node or pod fails. What happens?
Okay. The first things, I would use Kubernetes to run my pipelines, but I would define checkpoints in the workflow script so that the workflow engines will save the completed task, and if the task is failed, I will also tag the intermediate files. So if one task fails, Kubernetes will spin up the new pod or nodes and run on them, and the workflow engines will make sure that instead of restarting the task again, it will resume from there. So Kubernetes help us for help us to retry the failed jobs by spin up the new pods or nodes.
Okay. Exam is over. How was your exam?
Fine.
How was it?
It's fine.
It's fun.
Fine,
Brother.
fine. Okay.
Fine. Okay, fine. Okay, I was about to say it's not fun, man. Just compiling your results. Okay. A'udhu billahi minash shaitanir rajeem. Bismillah ar-Rahman ar-Rahim. So, mashallah, you passed your exam. The exam is over. We started at 10:49. It's 11:42. Still a few minutes remaining.
Here's what I found.
No, there's no need, Siri. So in the presentation, you secured 20 out of 25, which is 80%. In the Q&A, you secured 21 out of 25, right? So 3 and 4, 7, 8, 9.5, yeah. So I will compile the results, once we are done over here. It's 84%. The combined total is 82%. You passed with good marks. Okay. So this is my recommendation for you. क्या करना चाहते हो? What do you want to do? You want to go to Germany?
जर्मनी इरादा था, शायद जॉब का हो या अभी फाइनल नहीं किया।
Okay. Wherever you want to go, there's a lot of jobs in Saudi Arabia. I'm working with many Saudi companies right now, and they're investing in genomics, and they're investing in multiple things. So if you go with this title, that this was your final project that you did, and you did all the labs, and you did all the Al Razak things. Al Razak karo. I cannot emphasize on why Al Razak is so important for you. ठीक है ना? Today I'm going to have a session with one of the students who is going to UK on a master's, right? Inshallah. So he got admission from both the places. He's going to have a word with me. I'm going to walk him through all the things, right? Join that session if you can. Al Razak is the key for your job, because there, all the labs are there. Interview preparation is there. Everything is there. That's our own AI model that we have developed, right? वो हमारी अपनी चीज है. It has my blood. So essentially, it's a carnivore AI machine. It's using my blood, essentially my intellect, right? So it answers and mimics basically in the same way as I do. And it is copying and preparing the people, making sure like that you are successful, right? So please usko follow that. Get all the labs done. If you want to go, this is October, November, December, January, February. February is the time a new session of masters is starting. Even if you get your certificate now, you may be able to get admission for next year. Should you target next year, February, or next year, September? If you ask me, I would say next year, September. How old are you? कितने साल के हो?
मैं 23।
23 के हो ना? So you're 23. Take your time. Go for next year, September. Whether it's States, whether it is Canada, UK, USA, wherever you want to go, it's up to you, right? Germany. But before you go, complete Al Razak program. Complete Al Razak ki sari labs. Everything, even your KYC, because the KYC based labs is going to prepare you for where you want to land. जहाँ उतरना चाहते हो ना, वहाँ. So that when you go there, you have the resume in your hand, which already has prepared you for the jobs of that market. तुम उस जॉब के लिए पहले से तैयार हो, right? ऐसा ही है ना? जाने से पहले तुम पहले ही तैयार हो.
मशवरा देते हैं
Sorry?
सर, आपके मशवरा देते हैं कि अगर 7 लैब कंप्लीट करो तो जॉब पे जाऊं या मास्टर के लिए जाऊं?
देखो, जॉब पे तो तुम अभी भी जा सकते हो, ठीक है ना? मिडिल ईस्ट में सब जगह, ठीक है? तुम पहले अल रज़ाक कंप्लीट करोगे, 6 मंथ्स का अल रज़ाक कंप्लीट करोगे, यू आर रेडी फॉर एवरीथिंग, जॉब मार्केट एंड फॉर द मास्टर्स. मास्टर्स का क्या फायदा होता है? द ओनली थिंग यू गेट इन मास्टर्स इज वन थिंग. यूके में कंप्लीट करोगे 2 साल का वर्क परमिट मिलेगा. कनाडा में कंप्लीट करोगे 3 साल का वर्क परमिट मिलेगा. यूएसए में कंप्लीट करोगे मैक्सिमम 3 साल का मिलेगा. 1+2 या 2+1 मिलता है. जर्मनी में कंप्लीट करोगे साल का देते हैं, वट एवर, राइट? जो भी है. Wherever you go, completing a master's degree from there enables you to get what? A work permit. But that is not sufficient for securing the job. You need the skills. You need practice to crack the interviews. You need to develop your stack. Go online on LinkedIn, mention, I did this today, I did that today, these are the labs I did today, I completed all of these things, I did this project, I did that project, I did this. This is how you build up your portfolio. And जो employers search कर रहे हैं ना, they will say, जो तुम्हारी presentation अगर मैं खोलूँ इसको, if I look at your presentation here, it will say, we are using Nextflow, Airflow, Cromwell, right? The GA4GH standard, the FAIR standard, right? All of these things. We need a guy who understands about genomics data, a guy who understands about these interoperability standards, a guy who understands this, a guy who understands this. And these are the keywords which are already mentioned in your resume, right? समझ रहे हो ना? looking at all of these things. ये तुम्हें तैयारी करेगा जॉब को लैंड करने के लिए. That's what you have to do. वहाँ मास्टर्स करोगे तुम्हें वर्क परमिट मिल जाएगा 1 साल के बाद, 9 महीने के बाद मास्टर्स जो भी खत्म हो जाए. बट तुम्हारा गोल क्या है? वहां पर जॉब सिक्योर करना और सेटल होना, राइट? उन दोनों कामों के लिए तुम्हारे पास स्किल चाहिए. That's it. बगैर मास्टर्स डिग्री के, बगैर वर्क परमिट के तुम आप पकड़ नहीं सकते. अगर तुमने ये सारी चीजें खत्म की, पूरा, मैं तुम्हें ये बता सकता हूँ, अगर तुमने, इफ यू कंप्लीट द होल अल रज़ाक प्रोग्राम, इफ यू कंप्लीट एवरीथिंग, द होल 12 months that you have to complete, and you pass your Kubernetes exams and golden QB astronaut exams, the QB astronaut and the golden QB astronaut, and you get all those things done, और तुम्हें जिस फील्ड में जाना है तुमने उसके अंदर स्पेशलाइजेशन भी पकड़, सब कुछ कर लिया, आई कैन गारंटी यू कि तुम्हें कंपनीज तुम्हारे लिए खड़ी होगी वो एयरपोर्ट के ऊपर बोर्ड लेकर, कम हियर प्लीज. जब मैं यूएस में उतरा, तो जब मैं कैलिफोर्निया जा रहा था काम के लिए, so they sent someone to pick me up, right? And it had a sign, and it had my name, Mohammed Faisal, right? सही है. So the guy was there, a driver coming for me, right? If you want that, you need to follow what I'm telling you to do, right? That's what you have to do. But if you do that, then yes, then no one can stop you, right? So गोरा जो था वो मुझे ड्राइव करके लेके गया ठीक है, मेरे अपने अपार्टमेंट से. दिस इज योर अपार्टमेंट, थैंक यू सर, थैंक यू सर. खड़ा होता कि कुछ दे दो यार, बख्शिश दे दो, कुछ दे दो. मैंने उसके हाथ में $10 दे दिए. वो खुश हुआ सर, $10 मिल गया. ठीक है, ठीक है. मैंने कहा जाओ यार, मजे करो यार, 10 से ज़्यादा मैं तुम्हें नहीं दूंगा. मुसलमान हो तो थोड़ा ज़्यादा दे रहा था उसको. ठीक है, सही है. दैट्स व्हाट वी हैव टू डू. सो प्लान करो, plan it out. May Allah give you more success, inshallah. Okay, I will compile these results. I will update the your report, inshallah. Do you have any questions for me?
No, sir.
Okay, may I ask your parents to make special dua for me? Jazakallah khair for your time. Subhanakallahumma bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilayk. Assalamu